Okay, let's now how the wave function can be applied in a situation. Bohari holds one end of the closed tau and wiggles it up and down with oscillation in second and amplitude 0.065. So you have closed lines and the Bohari hold is and wiggle up and down. So it will produce a wave. Okay, the speed of resultant wave is 0 to 10 and travels to the right. So we can sketch a problem. This is Buhari and it has closed lines and it shake up and down. And the wave speed is 10 meter per second, right? And it is traveling to the right. At t equal to 0, the left has a maximum displacement and it's instantaneously expressed. That means if we sketch the displacement versus time of the point here, it is at t. It is here. That means it start at some displacement, and displacement a is 0.065 meter. Okay, so we have this information. Then what type of a wave is produced? So since the particle oscillates perpendicular to wave propagation, so it is a transverse wave. Transverse wave. Okay. So next is determine the amplitude, omega, t, lambda, and k. So amplitude is given here because it's written somewhere here. Omega. So omega equal to 2 pi f, but we do not know what is f. So in the information, this says that one oscillation in second. One oscillation per second means that means 1 hertz. One oscillation per second. So this is 2 pi times 1. So you have 2 pi radian per second. Then what is the period? So since the period is just 1 over f, 1 over t, so you have 1 second of period. Then lambda. So we can have lambda from the relations of v equal to f lambda, and v is given 10, f is 1 hertz. So from here you can get lambda equal to 10 meter. Right. Next is the wave number. So wave number is defined as k equal to 2 pi over lambda. And here you have 2 pi over 10. Then you get 0.2 pi meter minus 1 because this is meter. So this is a wave number. Next is write the wave function of the wave. Okay, so we can have a wave function is a y as a function of a position as and time is equal to the amplitude 0.065 cos omega t. So omega, where is our omega? This is omega 2 pi t, and then kx. Kx is 0.2 pi x. So now we want to choose whether it is positive or negative. So since the wave moves to the right, so we choose negative. So this is the right front wave function of the wave. Next, write the equation for displacement as function of at the left end, which is y0t, and sketch the graph of displacement versus yt. So you have two tasks. First, write the equation. Second is the sketch the graph. Okay, so y as a function of 0 at t means that the particle at this point. So we want to first write down the equation. So it is just simply taking the general wave function. So we have y as at the x equal to 0, t 0.065 cos 2 pi t minus 0.2 pi 0. Okay, so now your x is 0. So just replace in the wave function, simplify it. So you have 0.065 cos 2 pi t only because you have 0 term here. How do we, so now we have the equation for the particle here. what is the graph? Okay, to sketch the graph, so we want to sketch the y versus time. Okay, the period of the oscillation is 1 second. Okay, we have calculated before. Okay, so the amplitude is 0.065 and this is minus 0.065. So just you have here, and it is a cost function, so your sketch will be like this. Okay, that means the particle here oscillates from here and then below and return back in one period of time. Okay, this is for this equation. How about a point of another questions that means position particle at somewhere somewhere here, maybe, I don't know, but this is 2.5 meter from the end. Okay, how we proceed? The same way we proceed, we just replace 2.5 because x is 2.5, t 0.065 cos 2 pi t minus 0.25, 2.5, and put it down. Okay, so you just replace a new value here. You have 0.065 cos 2 pi t minus this is 0.5 pi. Okay, so now you have a new equation for the particle somewhere 2.5 from the end. So how do we sketch this equation? Okay, so you draw the same thing. We have 0.065, 0.065. This is 1 second. T. Okay. So now we have a additional term here, so we cannot just draw a cost function, but we can evaluate this by putting down t equal to 0. So if you put t equal to 0, that means y as a 2.5 at times 0 is equal to 0.065 cos. So you only left by this expression because your time is 0. Okay, so if you evaluate this, you will find out that cos minus 0.5 pi, so make sure this is in radian. Your calculator must be put into the radian. So you have here, this is the position of the, that means you get 0, actually, right? Okay, so next, we do not know whether it is going up or going down. Okay, so to evaluate that further, we segmentize, we make a segment because this is 0.5 and this should be 0.25 second. So I put it a little bit here. So at t equal to 0.25, so you have y 2.5, 0.25 equal to 0.065 cos 2 pi times 0.25 minus 0.55. Okay, so if you evaluate the phase inside the bracket, so you will have this is equal to 0.065. Okay, so that means that it is at this position. Okay, further we don't need to calculate because the graph will not go over, it will just oscillate. So you will have the sketch is like this. Okay, so it will be different shape because of the factor here. That means this is a graph of displacement versus time for the particle at 2.5 from the left. Okay, next is write the equation for displacement expansion for time at position t. That means at 4 seconds, what would be the shape of the wave? What the equation and what is the graph? All right. So we just use the general wave equation. So y at any position at 4 seconds. So okay. So yeah, use the wave function 65 cos omega t. So omega t. So you have 2 pi times 4 seconds minus 0.25x. Okay, so you have this. Okay, simplify 0.065 cos 2, you have this 8 pi minus 0.2 pi x. Oh, sorry. So this is the bracket. Okay, now you have this is 8 pi, this is 0. So you have a y as a function of position at 4 seconds. It's like this. Alright, so now you have two variables. Let's make a sketch of y versus x. Now you have x, not t. Okay, because in the previous questions you have a y as a function of time. Now y as a function of the position. Okay, so from this equation we can get information of the amplitude 0.065 negative. So now this is not period, this is wavelength. The wavelength we got is 10 meter, right? Wavelength is 10 meter and cos 8 pi minus 0.25x. So now we want to know what is the value at x equal to 0. So just at x equal to 0, so y 0, 4 equal to 0.065 cos 8 pi minus 0.255 times 0. So you have 0 here. So it is just simplified to 0.065 cos 8 pi only. So what is the value of 8 pi? So the value of 8 pi is 0 if I'm not mistaken. So 8 times pi should be 1. Okay, so 1 means here. Okay, here. So that means in the next position, it should not go up, it should go down. For one complete oscillation, it would be like this. Okay, so this is a graph for y versus position. Okay, so you see that you have to be very particular. The question asks maybe at which time or at which position. So you have to make sure that you make a correct graph, whether it is displacement versus time or displacement versus position. Okay, so is it y as a function of x and time? This is the general wave function. Okay.